So our PBL topic is non-invasive way for predicting the heart blockage using ML. Basically, non-invasive stands for the objects which are injected through our body. Non-invasive means which is not injected but treated externally. So these are the contents which were guided by our guide and we have added it. So coming to the introduction, as we know, heart disease across the world are getting increased. In global index, first the main heart diseases are found in China. India is standing in second place and Russia is the third. So what is happening here is because of unhealthy diet plans or the unbalanced the food item what they are consuming leading to the heart diseases. So globally we are seeing 34 million deaths across the globally per year, and majorly we are seeing young people or in age people are getting heart attacks. Though they might be having just their age at 20 and 40, but they are having heart attacks. We can see many cases we have read, like while dancing, while exercising, they have been attacked by the they have been attacked by heart attacks, and it causes death, fatal death. So this is the main concern why we have chosen this problem.
Charge your phone.
Heart attacks, we to find the heart attack in earlier stages.
Single tap order.
Just one finger tap order. Minimize.
So as I was saying, early detection of heart blockages nowadays is tested by angiography. Where angiography is the method where it is an invasive method and very expensive. They inject a dye through our hand and the dye will be spread to our body. Once they are doing an X-ray, through that X-ray the doctors will be knowing that whether the heart is blocked or not. So what the concern here is, we can't do angiography in the respected fields. If I want to do it in my current environment, we can't do it. We need specialized environment for that. So what our idea is to detect heart status conditions in environments which is very feasible in any environment. It might be in college, it might be anywhere. So what is our idea basically is, as we know, heart has a sounds like heart normally beats like love. But the thing is, when heart is under a disease, it mainly has 7 types of diseases: aortic stenosis, aortic regurgitation, mitral regurgitation, mitral stenosis. Like these are the main 7 types where if heart is under any condition or under any situation. So what we are doing here is, we are collecting the different types of heart sounds. We are converting it into the spectrogram images, and those spectrogram images are fed into ML. So brief idea will be explained by my friends. So coming to the objectives, as I said, angiography is very expensive and it needs specialized equipment. So we are overcoming this by providing an hardware which will be very feasible in any environment. So many rural areas are lacking due to this advanced medical technology. If any person in rural, if you want to test their heart, he needs to visit any district hospital. Through our idea, they can check it in their villages. So ours is non-invasive, it is cost effective, and it is scalable. And it is very easy to assist the doctors to find what is the heart status in early disease. The next part will be explained by my friend.
Just a minute. So here, angiogram will be done after ECG, right? blood pressure. So if there we find any, if that there may be a chances of heart based on the patient reactions. ಆಯ್ತಾ ನರ್ವಸ್ ಫೀಲ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಪೇನ್ ಬರ್ತಿರ್ಬೋದು ಇದ್ದಾಗ ಇ ಸಿ ಜಿ ಮಾಡ್ಸಕ್ಕೆ ಹೋಗ್ತೀವಿ. ಇ ಸಿ ಜಿ ಇಸ್ ದ ಮೇನ್. ಇ ಸಿ ಜಿ ಆಮೇಲೆ ಇನ್ನೊಂದು ಇಕೋ ಅಲ್ವಾ? ಆ ಇಕೋದಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ಇ ಸಿ ಜಿ ವೇರಿಯೇಷನ್ಸ್ ತೋರಿಸಿದ್ಮೇಲೆ ಇಕೋ ಮಾಡ್ತೀವಿ. ಅದಾಗಿದ್ಮೇಲೆ ದೆನ್ ವಿ ಗೋ ಫಾರ್ angiography, ಬ್ಲಾಕೇಜ್ ಚೆಕ್ ಮಾಡಿಸ್ತೀವಿ. ಹೌದಾ? ಸೊ ನೀವು ಹೇಳ್ತಿರೋದು ಏನು ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಏನು invasive
ಏನೂ ಇರಲ್ಲ. Just
but what is the data set that you are taking?
yes, I will be explaining. Go to so heading towards the literature survey. Like for the example of non-invasive, how did we come to know that we need to do it in a non-invasive? So these are the authors and the titles of the research papers. For example, if you take from the authors like how here we came to know how we can use deep learning for heart sound signals using CA1 or ResNet. And in 2022, author Vaibhav had a key contribution in telling us how heart sound classification can be done using MFCs and MFS features with an accuracy of 93%. And in the same way, there are still many authors where we came to know how we can continue this. Heading towards the work plan. So as my friend discussed on how to do this, let's go through the work plan. The first thing, we take an input from the user from the audio recordings. From those audio recordings, we use spectrogram features like MFCC. So what does this MFCC do? The main work of MFCC is to take the special features from the recordings, like the input given by the users. It takes amplitude, pitch variations from the audio recordings. We also use zero crosstalk, ZCR. So why is this used? This is used to if there are any variations in the audio, like higher sound, higher pitch, we make it balanced in the this uses which changes the frequency of it. And the output variable, after all the processing by using ML for the training and all, the final output will be shown in the block 1 or normal. So if the hard blockage is normal, like if there is no hard blockages, then the output will be 0, or if there is any limit or minimal block, so then it will be 1. So this is the work plan. So first we take the input, we train the model, then using the spectrogram features, we take the pitches, frequency changes and amplitude. The next part, methodology, the step-by-step method of how this project works will be explained on the front page.
So, thank you, Rohit. So, coming to the methodology of the project, since we know what we are going to use here, as ma'am you also said, we are ECG, etc. There are so many things which are present. Here we are not using any invasive, it's a non-invasive thing, in which we are going to take only the sound waves of the art, using which we are going to predict whether the art is blocked or not. So the methodology starts with this, the data collection for art sound analysis. Since there are certain data sets which are available related to art sounds, which we are going to use, and we are going to collect our own things. Based on that, we are going to...
that's what I'm asking. What data set you are taking?
Sounds of the art.
Art sound.
So there are, for example, there is a data set of 7 different diseases which produce different sounds, 7 different sounds of the art, using which we can clarify. Like that's why we use MFCC, which will be very key part in differentiating the sound waves. There will be frequency deep down.
So based on the heartbeat sound.
Yeah, heartbeat sound.
Right?
Yeah. And gathering these two different things. For one is disease related thing, another is normal person art sound. Disease person art sound. We are going to train the model based on
Yeah,
that.
sound in the sense what you are taking amplitude.
Yeah.
First, no, sound, we will be converting that sound into MEL spectrogram.
Spectrum.
MEL spectrum.
That device what you are using.
Microphone.
Microphone.
Yeah, of course.
Yeah, what device you are using?
Or else even in stethoscope. Yeah.
Digital stethoscope, nowadays
Digital.
digital stethoscope contains the micro, there is mic.
Yes. Yeah, that's what you record it and
Yeah. From that we are going to collect the data. So the data is like this, 7 different eye diseases which are there. We are going to label them, the features, then a normal person. Then whenever we give a data, for example input given, is going to check whether it is matching for this or not. Based on that, we are going to differentiate whether the person is healthy or not. Establish a baseline, identify patient, collect audio recordings, and train a machine learning model and analyze RSM. So only the sound is not there. We are going to convert it into image. The sound is converted into image, which is MEL spectrogram, which will be in phase 2. So the algorithm selection, in algorithm selection we gone across 3 different things: CNN, LSTM, and even random forest. Majorly CNN and LSTM, why we choose random forest is a simple thing which we thought, but the major thing we focus on CNN and LSTM. Since the heartbeats in a waveform, we are going to get time series data it will be. So we are going to decide whether it will be in an image or a time series data. We took it as an CNN since we are going to convert that say time series data into an image. We are going to differentiate on basis of that. So we are choosing CNN. This is the approach we are going to use in phase 2 to get the output CNN. And the next part will be explained by my friend.
Acknowledgement tools. Here we use hardware type digital stethoscope. Digital stethoscope is used for hard sound recording. Next is laptop and GPU servers. This is used for training the model training. Here we use models like LSTM and CNN, convolutional neural network and long short-term memory. Here software are used for Python libraries like Librosa. Librosa is used to convert the hard sound into spectrograms. Spectrogram. Next is TensorFlow. TensorFlow is used for training the models of CNN and LSTM.
So that's what that heartbeat rate converted into spectrogram will be the input data.
Yes. Next is SysPY. This is used for removing the noise from the hard sound. Means here we applied many filters to clean the hard sound. Next is matplotlib. This is used for visualization, for showing the result. Next is Django and Flash. This is a web-based diagnostic tool. Here if you upload the hard sound file, it will give the output in digital form. Futures. Due to we have we do not have more clinical data. So next we should expand data with clinical training for better generalization to improve our accuracy in that. Next, here we develop mobile or web-based diagnostic tool for monitoring the patient. Next, here we connect with wireless health monitor to collect the real-time data of the patient. Conclusion is here we use non-invasive machine learning that use both CNN and LSTM that predict the heart blockage accurately and the sequential time series features of audio data. This machine learning system provides critical tools for early stage diagnosis. And in futures we use mobile expand the data through clinical training, as I said in futures, and develop the mobile or web-based diagnostic tool. Next slide.
As I was saying, there are 7 different types of hard sounds. Basically, if those 7 types of different sounds are present, or if we came to know that the person is having that sound, so we can 100% say that he is suffering from some of the heart disease. So that is the key practical what we have used, and these are the sounds how it will happen. Normal heart sound. The sounds which are coming after this are the 7 different.
This is normal.
This is a heart block sound. Aortic stenosis. Entrance stenosis. will be converting it into MEL spectrogram images, and we will be providing CNN as a labeled data sets, so that when we give a sample sound to our model, it will be saying which disease it is and what the which disease is this. Is it a normal or is this any one of these 7 types? Our model will be rating. Or if we want, we can implement this in the digital stethoscope as well. We need to say doctor to keep the stethoscope near the heart for 10 to 15 seconds. Then after 1 or 2 minutes, the output will be displayed on the system.
Okay, fine. It's good. But usually through the angiogram,
Yes.
what we find is what are the blockages are, where are the blockages are, number of blockages given, and what percentage of that blockage is there. So if it is 90% blockage area, 95% blockage area, and the patient will not be having the time to live.
Yes, sir.
So it's very hard situation. So will it identify that kind of situations?
It's from we can say that if the person is,
What you said.
I got it, ma'am. In the form of percentage, we are not able to do that because sound might vary, but we are able to identify which disease he is having just by the sound.
Again, we have to go for a angiogram.
There are 7 different systems. There are the only things which are there. So based on the sound waves, we can
But here you have not mentioned what are those 7 kinds of diseases.
No, phase 2 we are doing.
In phase 2 you are going to elaborate it, right? But what my question is you get.
Got it.
using that you can find the place where the organ belongs.
Yeah, that I am asking. In several veins will be blocked.
So
Getting
that
which vein is which is blocked and what percent of blockage is there, and still the person has the time to blast it.
and
ಈಗ ನಾನು ಆಂಜಿಯೋಗ್ರಾಮಿಗೆ ಹೋದೆ ಅಂತ ಏನು ಹೇಳ್ತಾರೆ ಹೇಳಿ, ಇದು ಬ್ಲಾಕ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತಾರೆ, ಇಷ್ಟು ಪರ್ಸೆಂಟ್ ಬ್ಲಾಕ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತಾರೆ, ಹೌದಾ? ಇದರಲ್ಲಿ ರೆಕಗ್ನೈಸ್ ಆಗುತ್ತಾ ಅಂತ
ಪರ್ಸೆಂಟೇಜ್ ಆಗಲ್ಲ, ಬಟ್ ಥಿಂಗ್ ಇಸ್ ಯಾವ ವೇನಲ್ಲಿ ಆಗಿದೆ ಎಲ್ಲ ಆಗಿದೆ ಗೊತ್ತಾಗುತ್ತೆ. ಬಿಕಾಸ್ ಏರ್ಟಿಕ್ ಸ್ಟೆನೋಸಿಸ್ ಅಂದ್ರೆ ಪಲ್ಮನರಿ ವೇನ್ಸ್ ಅಲ್ಲಿ ಆಗಿದೆ 100%. ಏರ್ಟಿಕ್ ಸ್ಟೆನೋಸಿಸ್ ಡೈರೆಕ್ಟ್
We are not medical students. I don't know in detail about the heart veins, different types of heart. ಎಷ್ಟು ವಾಲ್ಸ್ ಇದೆ ಅಂತ ಗೊತ್ತಿದೆ ನಮಗೆ, 4 ವಾಲ್ಸ್ ಇದೆ ಅಂತ ಗೊತ್ತಿದೆ. ಯಾವ ವಾಲ್ಸ್ ಅಲ್ಲಿ ಬ್ಲಾಕ್ ಆಗಿದೆ ಅದು ಗೊತ್ತಾಗುತ್ತಾ, ಯಾವ ವೈನ್ ಬ್ಲಾಕ್
ಅದು ಗೊತ್ತಾಗಲ್ಲ, but
maybe it is recognizing in which wall which kind of veins will be blocked, but what percentage
What
of blockage
percentage
is
is
there, it is not going to identify.
again for that I think we need to work a lot.
Yeah, work
It depends on
it's,
sound.
it's really good. What I'm saying is work is good, but you do it, enhance it.
Okay, that was all.